Okay, the key to understanding how to do these problems for 2.5 derivatives of trig functions is basically just doing as many as you can and getting these trig functions as well as all the other rules, the quotient and product rules, ingrained in your brain. So I've chosen a few problems here that you should go through, and what you really need to do is go back and practice the ones that I don't cover, and these answers are also posted in the answer key on Blackboard and in Google Classroom. So I've chosen a very basic one, A, and really this is just finding the derivative of sine of x minus cosine of x. So you literally, this is a difference derivative rule, meaning you take the derivative of this function minus the derivative of this function. So what we would say here is that f prime of x is equal to the derivative of sine, which is up here. The derivative of sine is cosine. So I take the derivative, this is cosine of x, minus the derivative of the cosine, which, remember, the derivative of a negative trig function, or excuse me, trig function that starts with a c is negative, so this would be negative sine of x, which literally simplifies to a positive. So f prime of x is equal to cosine of x plus the sine of x. This is your derivative. But again, it's about knowing the derivatives of your trig functions. Here we have a quotient. So if you recall from our previous section, the quotient rule is f prime of x is equal to f prime g minus fg prime over g squared. So what we need to do is identify what we have as f and what we have as g. So we're going to take f is the top, which is the tangent of x, and g is the bottom, which will be x plus 1. So I'll take the derivative of each one. So f prime, the derivative of the tangent of x, is secant squared of x, which comes from up here. And then the derivative of g, where g prime is, the derivative of x is 1, and the derivative of 1 is 0, so this is just 1. So now I need to use the definition or the derivative rule for a quotient. So f prime of x is equal to, it's f prime times g, so this would be secant squared of x times x plus 1, minus f g prime, so this is just the tangent of x, all over g squared, which is x plus 1 squared. This technically is your answer. You could extend this and say f prime of x is equal to, when I distribute, it's x secant squared of x plus the secant squared of x minus tangent of x all over x plus 1 squared, and either one of these is your final answer. It does not matter which one, unless it's multiple choice, so you'd have to be able to tell the difference between the two. So I did a basic, I did a quotient rule, now I'll do a product rule. So when we have a product rule, remember this is just fig-figgy, so we're going to say that f is equal to x cubed, g is equal to the cosine of x. So now we'll say f prime, using our power rule, is 3x squared, g prime is negative sine of x, and now we'll use our rule. So f prime of x is equal to f prime times g, so it's 3x squared cosine of x, plus f g prime. So in this case, it's f g prime, so it would be x cubed times negative sine of x. So I would just need to simplify this. So f prime of x is 3x squared cosine of x minus x cubed sine of x. Okay, in calculus, you no longer will have plus and negative. Okay, so let's move to the top of page 22. Okay, and I just chose a different quotient problem, just a random one, and then we'll go through some application. So again, we need to designate what is f. So f in this case is just going to be x. And then what is g? So this will be the cotangent of x. And again, it's practice with our trig derivative. So f prime is 1. G prime is negative cosecant squared of x. And if you have to look on the previous page, it's totally fine. So then f prime of x will be f prime times g, so 1 times the cotangent of x is just the cotangent of x, minus fg prime. So in this case, I'll have a double negative here, so I'll put this as a plus x cosecant squared of x, and this is all over g squared, so it's the cotangent squared of x. That's your final answer. You can't factor anything, and these definitely don't reduce because this is a term and not being multiplied. So in example 2, I'm actually going to go through an application, and here it's saying find the derivative given this product here, and then we have to evaluate the derivative at 0. So this is the same thing as finding the slope of the tangent line to this curve at 0. So there's just a couple different ways we can look at this. Since we haven't learned the chain rule yet, we actually need to make some simplifications here. So we're going to say that f of x is equal to, I'm going to multiply this out. So this is x squared minus 2x plus 1 times the sine of x. So that way I can use my product rule. So I'm going to say f is equal to x squared minus 2x plus 1. And then we have g is equal to the sine of x. So now when I take the derivative, this is actually easier because I can take the derivative of each term. So this will be 2x minus 2, and then g prime will be the cosine of x. So again, knowing your trig derivatives. All right, so now we'll just use fig-figgy. So we've got f prime of x is equal to f prime times g plus f g prime. So you can write it any way you want, cosine of x times that polynomial. Okay, so this is a hot mess here, but it doesn't really matter because typically it's not necessary to simplify when you have to plug in a value. So now that I have the derivative and I'm pretty confident in my derivative, I'm going to evaluate this derivative at 0, meaning I'm going to plug in 0 wherever I see an x. So here we have 2 times 0 minus 2 times the sine of 0 plus the cosine of 0. Have to be careful. 0 squared minus 2 times 0 plus 1. Okay. So the sine of 0, if you go back to the unit circle, is 0. So that means this whole product right here is 0. So I'm skipping all of that just because 0 times anything will be 0. Then you have the cosine of 0 is 1, so you have 0 plus 1 times 1. So the answer is 1. This is f prime of 0. So after all that work, I get this teeny tiny little answer of 1. Here in example 3, I will show you, this is a higher order derivative. Okay, so we're asking you to take the second derivative of the cosecant of x. So first of all, I have to take the first derivative, which would be dy dx, and the derivative of the cosecant, if you go back to the previous page, is negative cosecant x cotangent x, or you could write it negative cotangent x, it doesn't matter because it's a product. But now, with this being the product, I have to use fig-figgy for my second derivative, which means I need to say, okay, I want f to be equal to negative cosecant of x, and g to be equal to the cotangent of x. So I have f prime and then g prime. So I need to make sure I know my derivatives. So here, the derivative of cosecant of x is negative cosecant cotangent. So then the derivative of the negative is going to make this a positive. So this would be cosecant x cotangent x, and then the derivative of the cotangent of x is negative cosecant squared of x. And I need this to take the derivative of this to get the second derivative. So the notation looks like this. Okay, and it's f prime times g, so it would be the cotangent of x times the cosecant of x times the cotangent of x, which is really cotangent squared. Okay, which I'll fix in a second, plus f g prime. So negative, negative still keeps a positive, and this would be cosecant cubed of x. So literally, I could factor out a cosecant if I wanted to. You don't have to. and simplify this, but this is cosecant of x times cotangent squared of x plus cosecant squared of x, and this is your second derivative. So that's a higher order derivative. And in this case, you would look to see if this is from your hexagon, which is a Pythagorean identity, but it's not. So that would be your final answer.